Hello team, welcome back. Welcome to Terraform training. And today we will see how we can create the IAM roles, and with that roles how we can access the Amazon S3 bucket. So we will create the IAM roles, we will create the policies, we will create and attach that policy with the S3 bucket, and then we will create and attach a particular association of the role with the EC2 instance, and we will see if EC2 instance will be able to access the S3 bucket without any authorization or not. So let's go to the code editor and let's create the code files first. So as I told you earlier as well, inside the AWS IAM, we have created few admin users. So please don't execute any destroy from that particular directory. I will create altogether a new directory for all the AWS roles. So I will copy the AWS IAM and paste it here. Now I will rename this directory as AWS IAM roles. Inside the AWS IAM roles, I will delete the IAM users.tf. Now inside the AWS IAM roles, we have the provider.tf and we have the variables.tf. Let's create one more file over here and I will call it s3bucket.tf. In this file, we need to mention the code or the configuration code which will create the S3 bucket. Create AWS S3 bucket. And here is the configuration file to create the S3 bucket. I'm defining the resource AWS S3 bucket. Then I'm defining the resource name level up underscore S3 bucket. Then I'm defining the bucket name, right? Which is level up underscore bucket hyphen 143. Please make sure you will provide the bucket name which is globally unique, right? If you are going to provide the bucket name like test 123, test 145, so it may possible that your Terraform configuration will be failed, because in Amazon S3 is a global resource, so we need to provide the name which will not exist in the AWS. So I'm providing level up underscore bucket hyphen 141, and same is inside the tags. We have created the s3bucket.tf. Let's create one more file and we will call it IAM roles. The file name is imroles.tf. Over here, first we will create the roles. First, we are going to define the roles to access the Amazon S3 bucket. And here is the role resource which I have defined. The resource is AWS IAM role. The name of the role will be S3 hyphen level up bucket hyphen role. The name of the resource will be S3 hyphen level up bucket hyphen role. The same name I'm defining to the name of my role. Then I'm attaching the policy. Attaching the policy with a keyword assume underscore role policy. Inside the EUF block, you can define your JSON data. First, I'm defining the version of the policy. This could be 2012-10-17. Please make sure we are not going to change the version. This is the static value of the policy. Last time Amazon released the policy version in 2012, and till date this version is running, so we cannot change the version, otherwise we will not able to create the policy in Amazon. Then I'm defining the action. Inside the action I'm defining STS assume role, and inside the principal we are defining the entity, and for which entity I'm going to create this role, service ec2.amazonaws.com. Effect will be allowed, SID will be null. So this is the role which I'm going to create in the Amazon. Now what I need to do, I need to create the policy to attach the S3 role. So over here I'm defining the policy. The resource name is AWS IAM role policy. This is the resource variable. I'm defining the same resource variable inside the name of my policy. Then I'm defining the role on which role this policy will be assigned. So this policy is going to be assigned AWS IAM role S3 hyphen level up bucket hyphen role, which is same which I have declared over here, S3 level up bucket role. Then I'm defining the policy of this policy. Inside the EOF block, I'm defining the JSON data version 2012-10-17, which will be static, effect will be allowed, and action will be performed on the S3, right? Then I'm defining the resources, that which resources of the S3 will be accessible by this policy. I'm defining the S3 bucket level up underscore bucket hyphen 141. This is the same bucket name which I've created inside the S3 bucket. And second resource, I'm defining level up underscore bucket hyphen 141 slash asterisk. These are the two different statements. First statement is saying that this policy is applicable on this bucket, and second statement is explaining that this policy is applicable on the all content which is present inside the bucket. So we are defining the access on the bucket plus the content of the bucket. How we can attach that particular role to the EC2 instance? How we can do that? For this we need to define the instance identifier. and which will be done with the help of AWS IAM instance profile. I am defining the variable of the instance profile, then the name of the instance profile, and over here I'm defining that this instance profile is basically attached with the AWS IAM role S3 level up bucket role, then name, and this is the name of the role of the S3 bucket. Now, what else we need to do? We need to include the create instance.tf as well. So we will include the create instance.tf from the RDS. I will copy this and paste it here. Right? We have the create instance.rdf. Over here we have the key value pair. We are not going to remove it. It will be same. Then we have the AMI, machine type, availability zone, key name. We have the VPC security group IDs and subnet. We will remove these. And over here we need to provide some meaningful data so that this instance can identify this particular role. And how we can do that? We can do that with the help of the instance profiler. So we will define the key over here, and key will be IAM instance profile, put equal, put this name, dot the name of the profiler, which is this, then dot name. Right? So these are the configuration file which we have created. Now let's commit out these files. Once the commit will done, we will go to the machine where we are executing the Terraform. We will go to the Terraform directory and execute git pull. You can see a new directory AWS IAM roles is being created. We will go to the Terraform, and instead of the AWS IAM, we will go to the AWS IAM roles. Put ls. Over here we have the IAMTF provider.tf, s3bucket.tf, and variable.tf. Let's execute Terraform init. Clear out the console, and for the instance execute the SSH keygen as well. The command will be same. SSH key is generated. Now let's execute the Terraform plan. Provide the secret. So plan is to add 6 resources, right? Execute Terraform apply. Provide your secret key, hit enter, and provide your confirmation. So you can see it has created all the resources and your instance creation is in progress. We have to wait until the instance will be created, and we are getting some error that only alphanumeric characters and hyphens are allowed. We have provided the underscore, so we need to modify the bucket name. So let's modify your bucket name. So in the code files, we need to go to the S3 bucket, and over here let's remove this underscore with the hyphen. Let's remove the resource name as well and the tag name as well. Save this file, and inside the IAM roles, we need to modify the value over here as well. Save your file and commit these files. Once commit will done, go to the Terraform machine, execute git pull. You can see the IAM role and S3 bucket have the changes. Execute Terraform apply again. Provide your secret, hit enter. Provide your confirmation, hit enter. And you can see one resource added and one is changed. We have changed the role and added the bucket. This is the IP of my machine, right? Let's go to the AWS. On the AWS, we will go to the S3, and you can see we have the S3 bucket created level of hyphen bucket hyphen 143. If we will open the S3 bucket, we don't have any object present inside the S3 bucket. Let's do one thing. Let's go to your Terraform machine again and put SSH. Complete the command, just replace the public IP in your command. I will replace the public IP with this IP. Hit enter, provide yes, and you have logged in inside your AWS machine. Clear out the console and execute sudo -s to switch to the root user. You can see we have switched to the root user. Now let's execute apt-get update. It will update your package manager. Once done, now what we need to do, we need to create some content inside my AWS S3 bucket from this instance, because we have attached the profiler with this instance which have the role to create the content or access the machine of the S3, to create the content or access the S3 bucket. But to create the content from this machine to But to create the content from this AWS machine to S3 bucket, we need the AWS CLI. And to execute the AWS CLI, we need the Python environment. So what we will do, first we will install the Python environment like apt-get install. We will execute python pip, and we will execute install python-dev. Hit enter, provide your confirmation. It will install the Python dev and Python pip on your machine. We have to wait. It will take some time, so we have to wait. The installation is done. We will clear out the console, and now we will install the AWS CLI with the help of the pip. So pip install AWS CLI. hit enter. You can see it is installing the CLI. We have to wait until the CLI will be done, and CLI is installed. Clear out the console. Now let's put ls, and we don't have any data. Let's create some file over here. Echo hi, this is my Terraform class for AWS IAM. I will write this content to the myfile.txt. Put ls, we have the file. Let's get the content of the file. We have my content. Now what we will do, we will upload this file to the AWS S3 bucket which we have created. For this we will execute the command aws s3 cp, then your file name, which is myfile.txt, s3 colon, then you need to provide your bucket name. In my case, my bucket name is this. I will provide my bucket name, hit enter, and see, file is uploaded. So from my EC2 instance, I don't need to provide any manual access to the S3 bucket. My EC2 instance have the complete access of my S3 bucket. And how these access become possible? Because my instance is using the instance profiler which have the S3 bucket role. So I can upload, download, and perform anything on the S3 bucket. If you will go to the Amazon, refresh your web page, you can see I'm getting the files myfile.txt, which is just uploaded on my S3 bucket. So this is the way how we can manage the resources, how we can deal with the rules, policies, users, and the groups in AWS. If we will go to the AWS, we will go to the instance which is running, EC2. Let's go to the running instances, open your instance, and over here you are getting the complete description. The AMI role which is using is S3 level up bucket role, C. Right? If you will go to this role, then these are the permission of this role, S3 level up bucket role policy which we have defined, and this policy have the this JSON. See, this is the same JSON which we have applied. So team, I hope right now you are pretty much clear that how we can deal with the IAM user group role policies, and how we can open the policies and roles from one service to another service, from user to group and group to the instances. So let's go back to the Terraform machine again. Exit out from your instance, right, and execute Terraform destroy. Provide your key. Once it will ask, provide your confirmation, and all done. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will discuss about the AWS EC2 auto scaling. In the AWS, we have the concept of the auto scaling. In the auto scaling, AWS auto scale and auto descale the resources, right? AWS auto scaling feature is applicable on the multiple resources in AWS like the load balancer, EC2 instances, AMIs, but we are going to discuss the auto scaling on the EC2 instance only. So first we will see what are the condition and what are the prerequisite which is required to auto scale the EC2 instances. So let's start with. First, let's discuss about the need of the auto scaling. So in the traditional model, we have the servers, and in the servers, the resources are limited. It doesn't matter that my traffic is few thousand or few millions. I have the static resources, and all the traffic, either that is low or high, is being served by these resources. So for an example, we can take an example. All the time I'm executing 10 servers. It doesn't matter that 10k users are live on my service or 10 million users are live on my service. Only 10 servers are running my application in the infrastructure. But auto scaling completely changed this model. In the auto scaling, you can increase the number of servers when the load will increase on your application, and you can also decrease the number of server when the load will decrease on your application. And this feature make public cloud more beneficial. In terms of the business stability, you are getting the desired service. Your user is not getting any kind of delay, any kind of maintenance, or any kind of unresponsiveness, because whenever the user are increasing, whenever the load is increasing, the required number of servers are basically being provisioned in the AWS without any downtime. And when the traffic is low, the unnecessary server will be removed by the auto descaling by the Amazon. So this will benefit your customer, plus this will also a cost friendly model. We are not bound to execute few number of server each time, right? It may possible that we have the low traffic that only two servers are running, and it may also possible that we have the peak traffic then 200 servers are running for my application. So auto scaling ensure that the Amazon EC2 instance are sufficient to run your application. When the number of requests increase, the load on the servers also increase. In that case, AWS will identify and auto scale the resources as per the defined configuration. For the auto scaling is not by default configured on the EC2 instances. We need to configure the auto scaling for the EC2 instances. Auto scaling group is mandatory to auto scale the EC2 instances. So whenever we want to make the EC2 instance auto scalable, we need to define the auto scaling group in AWS. Let's discuss about the component of the auto scaling, and first one is the group, right? The auto scaling group is a logical group which will contain the collection of EC2 instance with the similar characteristics for scaling and management purpose. So suppose your application is executing the Tomcat web application, or your application is executing the Nginx web server. Only two servers are running for your application and you have configured the auto scaling group. If auto scaling group is not aware about the characteristics of your servers, then how it will scale up the Nginx server or the Tomcat specific server? So we need to maintain the similar characteristics for all of the server which is going to be auto scaled by the auto scaling group. And for this, we will use the auto scaling group template. Auto scaling group will follow a template, and on the basis of that particular template, the new servers will be spin up in the cloud. Auto scaling group also maintain a fixed number of instances even if the instance become unhealthy. It means inside the auto scaling group, if you have defined the minimum number of servers 3, it means you always need 3 server. It doesn't matter that traffic is there or not, right? In that case, auto scaling group maintain the minimum 3 healthy server in your application. As soon as server or instance become unhealthy, auto scaling group will basically terminate that instance and spin up a new instance with that configuration. So how auto scaling group will check the server is healthy or not? So auto scaling group keep checking the EC2 instance health using the health checks. So you need to configure the health check for your server, and as soon as the health check will be failed, it will mark your server unhealthy, right? And as per the configuration you have defined, it will terminate that server and create a new server with the same configuration. If any instance become unhealthy, the auto scaling group terminates the unhealthy instance and launch another instance to replace it. Auto scaling group can increase or decrease the number of EC2 instances. So auto scaling group is just not used to increase the number of servers. Auto scaling group also decrease the number of servers. So whenever for the heavy load for the peak hours, auto scaling group is increasing the server as per the policy. Then for the normal traffic or for the low traffic, you need to define some more policies so that auto scaling group can decrease the number of servers as well, which will be a very cost effective for your business. The next component of the auto scaling is the launch configuration. Launch configuration is a template used by the auto scaling group to launch EC2 instance. As I told you that how auto scaling group will identify the configuration of your server. For that, you need to create some template, and that template is called launch configuration. User specify the Amazon machine type AMI, instance type, key value pairs, security groups, availability zone. There could be the n number of parameters you need to define inside your launch configuration. It also include the scripts which need to be executed after the boot. User can also edit the launch configuration. It means whenever you have created the launch configuration, that launch configuration is editable. You can edit the launch configuration at runtime so that the new instance which will be launched by the auto scaling group will have the updated launch configuration. The next component in the auto scaling is the scaling plan. Scaling plans tell auto scaling when and how to scale. So that is pretty much clear that we need to scale the servers. But when we need to scale the servers and how we need to scale the server, that thing is basically maintained by the scaling plan. Maintaining current instance level all the time, and there could be the multiple scaling plans. The first one is the maintaining current instance level all the time. It means user will define that you need to maintain these number of servers, right? You need to maintain 3 number of server, 5 number of server, or 10 number of server. User can configure and maintain a specified number of running instance all the time in the auto scaling group, so that as soon as any server went unhealthy, auto scaling group or auto scaling feature will create a new instance with the same configuration. The second is manual scaling. In the manual scaling, user specify only the changes in minimum and the maximum or desired capacity of the auto scaling group. Auto scaling group maintain the instance with the updated capacity. So suppose you have created the auto scaling group, and in the auto scaling group you have defined one minimum server and five maximum server. Now in the production you feel that we need more server, and you have updated your auto scaling group. You have updated that we need minimum 3 servers and maximum 5 server. In that case, this is called manual scaling. You are updating the minimum value of your auto scaling group. So one server was minimum, one server was running. As soon as you will update the minimum server count 3, auto scaling group will initiate 2 more instances and make sure that all 3 servers will be running. The next one is the schedule based scaling. This is very common in the e-commerce kind of website, because in these days e-commerce website have some promotion plans. They have some plan like we need to promote sale during the festive seasons, right? We need to promote some sales during this particular period of time. So they can define a schedule based scaling. So whenever the client is planning to promote their business, they can schedule that particular thing inside the auto scaling group, and auto scaling group can perform the auto specific, and auto scaling group can scale the EC2 instances on the defined specific time. And the most advanced is the scale based on demand. You don't need to go with the manual, you don't need to go with the minimum requirement, you don't need to go with the schedule base. Define the auto scaling group scale based on demand. As demand will come, I will scale my infrastructure. As demand will reduce, I will reduce my infrastructure. This is the most advanced scaling model, resource scale by using the scaling policy. We will define the increase scaling policy and the decrease scaling policy as well. So whenever I need to scale the resources will be increased, and whenever I need to decrease the resources will be decreased. And that all depend on the load and on the traffic on your application. You don't need to maintain the minimum, any manual intervention is not required, no schedule based scaling is required. This is the most advanced scaling model, and this is a quite beneficial for your business from the cost point of view. So that's all about the scaling. In the coming lecture I will show you a lab how we can scale the EC2 instance with the help of the Terraform. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see a lab on EC2 auto scaling. We will create the Terraform configuration file, and we will see how we can set up the EC2 auto scaling with the help of the Terraform. So let's go to the code editor and let's create the configuration file for the EC2 auto scaling in Terraform. So here we are on the Terraform. I will close all these files and I will create one more folder called EC2-auto scaling. From the previous lecture or from the previous section, I will copy the variable provider.tf and create instance.tf. You can see we have copied all three files, create instance.tf, provider.tf and variable.tf. Shortly, we will modify the create instance.tf as per our need. First, let's set up some auto scaling and auto scaling policies. So let's create a file called autoscaling.tf. And very first, what we need to define, we need to define the launch configuration. So I will define the auto scaling launch configuration. So over here we have defined the launch configuration. We are creating the resource AWS underscore launch underscore configuration. This is the name of the resource, level up hyphen launch config. I'm going to provide the name prefix same, level up hyphen launch config. So basically this string will be the name prefix of all the instances which will be launched by this particular launch configuration. Then we are taking the image ID, and inside the image ID we are taking the AMI. For the AMI, I'm executing lookup inside the where's AMI AWS region. If you remember, inside the variable we have defined the AMI as a map type, and from here we are taking the US East 2 and US West 2 and US East 1. So it will automatically identify the AMI as we have discussed in the earlier lecture. The instance type, I'm taking it t2.micro. Then we are taking the key name. In the key name we are taking AWS key pair, value of the AWS key pair, and then the key name, right? So we have defined the launch configuration. What next we need to define? Next we need to define the auto scaling group. We will define the auto scaling group after the launch configuration. So over here we are defining the auto scaling group. The resource name is AWS auto scaling group. Then we have the name of the auto scaling group, level up hyphen auto scaling. This is going to be the name of your auto scaling. Then we are defining the VPC zone identifier. Over here we are defining the zone in which zone the instance can be create or instance can be launched. So we are defining US East 2B and US East 2A. Inside the launch configuration, we are providing the name of my launch configuration by help AWS launch configuration, then label up hyphen launch config, which is the name of my launch configuration dot name. The minimum size of my autoscaling group is 1. At least one EC2 instance will execute in this autoscaling group. At max size is 2. At max, 2 instances can be scaled in this autoscaling group. The health check grace period is 200. It means after 200 seconds of the continuous health check failure, new instance will be created. Then the health check type is EC2. Force delete is true. Then we are defining few tags as well. So we have defined the launch configuration and we have defined the autoscaling group. What else we need to define? We need to define the policy. So let's create one more Terraform configuration file. So we need to define the Terraform configuration policy. So we need to define the auto scaling configuration policy. So in the auto scaling configuration policy, first we are defining the scaling alarm. It means at what policy the auto scaling group will be scaled. So we are defining one resource, AWS auto scaling policy. This is going to be the name of your auto scaling policy, level up hyphen CPU policy. The auto scaling group, on which group this policy is assigned, is auto scaling group, then level up hyphen auto scaling, right? Dot name. Adjustment type is change in capacity of the resource group. Scaling adjustment is 1. It means scale the node one by one. It doesn't mean that you can scale up the node, all the nodes at one time. Scale node one by one. Cooldown period is 200 and scaling policy type is a simple scaling. We have defined the scaling policy. Now what else we need to define? We need to define something which will monitor the EC2 instances. So we need to mention the CloudWatch monitoring as well. So auto scaling, CloudWatch monitoring. If we don't monitor the EC2 instance, then how auto scaling will be triggered? So we need to put up some monitoring over here. So we will put up the CloudWatch monitoring on my EC2 instance group. So team, you can see over here, I have defined the AWS CloudWatch metric alarm. So the resource is AWS CloudWatch metric alarm. The name of the resource will be level up hyphen CPU alarm. Here I'm taking the alarm name level up hyphen CPU alarm and the alarm description. Alarm once CPU uses increase. The compression operator is greater than or equal to threshold, right? This alarm will be triggered whenever the alarm value will be greater than or equal to the defined threshold. The evaluation period is 2. Metric name is the CPU utilization. I'm going to put the metric or the alarm on the CPU utilization and the namespace is AWS EC2. The period of the alarm will be 120. Statistic will be average. It means for a 120 second, it will monitor the 2 evolution and threshold is 30%. It means in a period of 120 second, if there is a 2 evolution where the average CPU is going above 30%, then this alarm will be triggered. Here I'm taking the dimension of this alarm, the auto scaling group, and we are defining the auto scaling group which we have created over here, right? This is the auto scaling group we have created. So I'm defining the auto scaling group inside the dimension, then taking the action enable is true and alarm action. What is the alarm action? Once this alarm will be triggered, what is the action this alarm will perform? Inside the alarm action, I'm defining the policy. The policy which we have created, it means increase the EC2 instance. In the similar way, we have defined the policy for the auto scaling. We need to policy for the auto descaling as well. So define the policy for auto descaling. Why auto descaling policy is required? Auto descaling policy is very much required to maintain your cost, right? We know very well that once the load will increase, AWS will increase the instance. How AWS will decrease the instance if auto descaling policy is not defined? It will keep the current state of the machines. So we need to make sure that if we are scaling the nodes, then we also need to descale the nodes whenever the traffic will reduce. So we are defining the auto descaling policy as well. So what I will do, I will copy the auto scaling policy, paste it here, and I will change the configuration as per my need. Here first I need to modify the name. Let's take it level up hyphen CPU policy, scale down, keep the same change over here. It is going to apply on the same auto scaling group. The adjustment will be again change type. And what is the scaling adjustment this time? Earlier we was increasing the one node. and this time we will decrease the one node. The cooldown period will be 200 again, and the scale policy will be simple scaling. So in the earlier policy, what is happening, we was increasing the C we was increasing the nodes. This time what we are doing, we are decreasing the node, right? And we are decreasing the node one by one. We are not decreasing the node all the nodes instantly. We will gracefully remove the nodes from the AWS infrastructure. Similarly, we need to define the auto scaling CloudWatch as well. Simply we need to define the auto descaling CloudWatch. Here I will copy the same CloudWatch configuration and modify this as per my need. So let's modify few values. I will keep it like level up hyphen CPU alarm scale down. The same change I will do over here. We will alarm once the CPU usage decrease, and in the comparison operator, instead of the greater than or equal to, we will change it to less than or equal to. Evaluation period will be 2. Metric name will be CPU utilization. Namespace will be AWS EC2. Average period will be 120 seconds. Statistic will be average. Let's change the threshold. Suppose we want to descale the machine if the average CPU of the threshold less than 10%, right? So we will keep it less than 10%. Auto scaling group will be same. We are using the same auto scaling group, but the policy will be updated. Here we was using the level up CPU policy, but this time we will use this policy. Level up CPU utilization scale down. I will keep it over here. So these are the prerequisite we have done. We have defined the launch configuration, we have defined the auto scaling group, the policy for the scaling and descaling, and the monitoring for the scaling and the descaling. Also, we need to make sure whenever we are defining the auto scaling group, right? You can see over here we are defining the auto scaling group, right? And here we are taking the minimum size one. Then do we really need to define the create instance as well? We need to create the instance explicitly. Is that required? So what we will do, we will remove this create instance.tf file. I will simply delete this file. So what do we have? We have the autoscaling.tf, we have the provider.tf, and we have the variables.tf. Let's do one thing. Let's save your code and commit your code. Once the code commit will done, we will go to the machine where we are executing the Terraform. We will go to the Terraform directory and execute git pull. You can see the new location is basically created, EC2 autoscaling inside the Terraform for AWS Cloud 2. We have three files, autoscaling.tf, provider.tf, and variable.tf. Let's go to this location, put ls. We have three files. Let's create your SSH key over here. Key is generated. Clear out the console and execute Terraform plan. Provide your secret key, hit enter. Oh, we forgot to initialize the Terraform init. Again, clear out the console and execute the Terraform plan. And we are getting an error. The error is related to the key pair. That is genuine error because what we have done, we have removed the create instance.tf and we have used the key inside the auto scaling config launcher, but we are not defining this resource anywhere. So first we need to define this resource. So let's mention this resource as well, generate key, and we will get the reference from the create instance.tf. Over here you can see we are generating this key. I will simply copy this and paste it here. That's it. Save your file, commit your code, execute git pull, and execute the Terraform plan again. Terraform plan is successful and it is going to add the 7 resources. Let's see what resource it is going to add. So first it is going to add the level up auto scaling group, auto scaling policy, auto descaling policy, cloud metric alarm for the scaling, cloud metric alarm for the descaling, key value pair, and the launch configuration. Now I will execute the Terraform apply. Once it will ask provide your confirmation, hit enter, and it will create the resource for you. Now you can see it is creating the resources. We have to wait until all of the resources will be created. The resource creation is still in progress and all resource creation is done. Let's go to your AWS account. Here we are on AWS Cloud Console Management. Let's go to the EC2 and you can see one instance is running. Open this instance. Let's check. Level up custom EC2 instance is running. T2 micro machine US East 2A and check status is initializing. Here we are getting the key name, level up key, and we are getting the other things. If you remember, I have not created any instance in my Terraform configuration. So how this instance is being created? This instance is basically being created with the help of the group. Over here you can see we are getting the CloudWatch alarm as well. Until now, no alarm is configured. Here, if we will go to the tags, then inside the tag you will get AWS auto scaling group. Group name is level up auto scaling. So this instance is basically initiated by the auto scaling group. If you will scroll down in your AWS console, you will find the option auto scaling group. Let's open this option, and you can see here we have an auto scaling group, right? Level up auto scaling, which we have created. The minimum count is 1, maximum count is 2, availability zone is US East 2A and US East 2B. If you will open this auto scaling group, here we are getting the desired capacity, minimum capacity, maximum capacity, the resource name, date created, the group name, and we are getting the other information about the group. That this is the key pair, this is the AMI ID, and other required information of the group you can get over here. If you will go to the activity, you can monitor the group activity. In the auto scaling, you can see we have the two policies: level up CPU policy and level up CPU policy scale down. Instance management, we have only one instance. Inside the monitoring, you will get the auto scaling monitoring and you will get the EC2 monitoring as well. So this is the auto instance group. Let's open the EC2 dashboard in a new tab. Go to the AWS and search for the CloudWatch. You will get the option inside the monitoring resource and applications. Open the CloudWatch, go to the alarms, and inside the CloudWatch alarms we are getting two alarms. You can see one alarm is in red and another alarm is in OK. Let's open both of the alarms. First go to the alarms which is in the red, and here we have the alarms level up alarm scale down. Let's open this in a new tab, and let's go to the alarm which is in the OK state. This is level up CPU alarm. Let's open this also in a new tab. Why this alarm is in the red state? Why this is in the alarming state? This is in the alarming state because the CPU utilization is continuously less than 10%. So the scale down alarm is in the red state. Then why the scale up alarm is in the green state? Because no more spike is more than 30% average CPU. Now what we need to do? We need to trigger this alarm, right? Once this alarm will be triggered, a new instance will be launched. And how we can do that? To do that, we need to make the CPU uses more than 30% on the instance which is launched. So let's go to the EC2 management. Let's go to the instances. Copy the external IP of your instance. Go to the Terraform machine, and in your Terraform machine, SSH to the machine which you have already spinned up, right? So I will replace the public IP from my current public IP. The key name is same and the user is same. Hit enter, provide confirmation. Once you will logged in your AWS machine, clear out the console and switch to the root user sudo -s. Now what I need to do, my motive is to put some load on this machine so that the auto scaling can be triggered. For this, we need to download some tools. So first what I will do, I will update the package manager apt-get update. We have to wait until the update will done. As soon as the update will done, we will install the stress, apt-get stress, right? This is the utility which will put load on your CPU. We need to put apt-get install. We will install the stress. Stress is installed. Now to put the load on your CPU, we need to execute a command like stress hyphen CPU, define the number of CPU to hyphen timeout. For how much time we need to put the stress on the machine, let's define 300 second. Hit enter. It is in the execution. Now let's go to the browser and let's go to the CloudWatch which have the graph for the CPU utilization. I will reload this, and you can see graph is slightly coming up. We have to wait until the graph will cross the 300 threshold. We will reload this again, and now if you will refresh your screen, you can see both of the alarm in the true state. If you will go back to the scale down, you can see the CPU utilization is more than 10%. So CPU utilization is more than 10% for a particular period of time, so that this alarm comes in the green state. If you will go over here and refresh the screen again or reload the screen again, You can check the CPU utilization is more than 30% for a particular period of time. So let's go to the EC2 instances and let's refresh this. No new instance is basically triggered. We have to wait until the new instance will be triggered. So we will wait on the CloudWatch. You can see one alarm is getting in the alarm state. Let's open and see what alarm is in the alarm state, and level up alarm CPU is in the alarm state. Open this and the alarm is saying CPU utilization greater than 30% for the two data point within 4 minutes. If we will go to the EC2 instance, refresh this, see, new instance is basically spinned up. This is the same instance, level up CPU EC2 instance. This is in the initializing state. So as soon as the CPU utilization is up, alarm is triggered, the alarm action is also triggered. If we will go to the groups, we will go to the auto scaling groups, open this in a new tab, open the auto scaling group. You can see desired capacity 2, minimum capacity 1, maximum capacity 1. If we will go to the activities, see, new instance is basically triggered. And if we will go to the monitoring of the EC2, we can see we are getting the CPU utilization more than 100%. So this is the way how the auto scaling will work. Let's stick to the activity stream. Go to the EC2 instances, keep it refresh. New instance are running. Let's go to the terminal. The stress is still running because we have configured it for the 300 second, which is 5 minutes. Let's wait until the stress will be completed. And after the 300 second, we will see this stress will be completed. CPU will be cooled down and auto scaling group will terminate one node as per the auto descaling policy. So we have to wait until all 300 second will be done. Now if we will refresh our alarms, you can see the 5 minute is completed and CPU is coming down. Now the current CPU utilization is just 3%, right? And both of the alarms are in the green state. We have to wait until the descaling alarm will come to the red state and it will descale the node. So let's keep the screen refresh, and after 120 seconds the descaling alarm will be triggered. You can check one alarm is moved to in the red state, and if we will go to the alarms, this is the descaling alarm. It means now it is time to cooling down the servers. So it will trigger a new activity over here in which it will terminate the instance. I'm not sure which instance will be terminated, but one instance will be terminated. So I will keep it refresh, and you can see the activity is in progress. Terminating instance with ID 21D6, and this is the first instance which was created. So it is not terminating the last or the latest instance, but it is terminating the old instance. If we will go to the EC2 management, we will refresh this. One instance is being terminated. So this is the way how auto scaling and auto descaling work in the AWS. And this is the way how we can configure the Terraform configuration file for the EC2 instance, auto scaling and the de-auto scaling. Let's do one thing. Let's go to the Terraform and execute Terraform destroy. Provide your key, hit enter, and it is terminating all of your instances. Provide the confirmation. So team, we have seen the auto scaling and auto descaling. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will discuss about the load balancing in AWS. So first we will discuss about the load balancing, what kind of load balancers are available in AWS, and in the coming lecture we will see a lab with the help of the Terraform load balancing in AWS. So let's start with. So in Amazon AWS, Elastic Load Balancer is a purpose-built service for distributing the workload. In the last lecture we have seen about the auto scaling, and we have already seen that the basic concept of the auto scaling is the load. So when we are getting the more traffic, when we are getting the more load, then we need to increase the number of nodes. But what if the traffic is not going on the new nodes? Whenever we are increasing the number of node, we also make sure that the new node will start serving the traffic. So for that we have the load balancers. Load balancer will distribute the incoming traffic across the targets attached to that particular load balancer. So we can manage the workload. So in the peak hours, when our web application or when the applications have a lot of traffic, the load can be distributed with the help of the load balancer across the all available instances. For Amazon ELB or Elastic Load Balancer, user must specify one public subnet for at least two availability zone. So it is required to provide at least one public subnet and at least two availability zone whenever we are going to create the ELB in AWS. AWS ELB or Elastic Load Balancer will accept the incoming traffic from the client and route that particular traffic to the available targets. That is the basic principle of the load balancer. Load balancer is a single point for the incoming traffic, and then it will distribute the traffic across all the available instances or across all the available targets. To check the healthy or unhealthy instances, AWS ELB will monitor the health of the registered target and send traffic to only healthy targets. So if we have a load balancer and we have a two instance attached to that particular load balancer, due to some reasons, if one instance is not responding, then AWS ELB will identify that that particular instance is not healthy with the help of the defined health check, right? So as soon as health check will start failing, AWS will mark the instance unhealthy and no further traffic will be sent to that particular node. If you will delete your ELB, then that will not delete the associated target. So there is no cascade delete in the AWS ELB. Also, the ELB delete by default prevented, and you cannot directly go and delete the ELB, right? You need to provide the confirmation before deleting the ELB in AWS. AWS ELB also supports the SSL offloading. So whenever the traffic is going with the help of the HTTPS or encrypted traffic, ELB will offload that particular SSL. ELB can decrypt that traffic and then send the traffic to the target. So within the Amazon network, traffic will flow in the decrypted form, right? The traffic, the encryption will be decrypted at the ELB side, not at the target side, because ELB and the instances all are using the same VPC. So within the same network, traffic will be decrypted whenever the traffic is flowing from ELB to target or target to the ELB, right? ELB will also offload the SSL plus also encrypt the traffic whenever sending the traffic to the client. So here is the sample of the ELB. We could have the multiple clients connected by a laptop, mobile, tablet, or any kind of resource for which your ELB is opened. Either that could be the physical hardware or the software. Then all these resources are basically have the single point of contact to connect with the service. And that single point of contact is the ELB load balancer. ELB load balancer will accept all kind of incoming traffic from the multiple resources and then send that traffic to the EC2 instances. And whenever ELB will send the traffic within the AWS, that traffic will be distributed. It means the traffic will distribute across the available EC2 instances. If a single EC2 instance is running, then all the traffic will fall on that particular EC2 instance. But if multiple EC2 instances are running and attached to the ELB and they all are healthy, then traffic will be distributed across the all instances, not a single instance. That is the primary application of the load balancer. In AWS, we have the three kind of load balancer. First is the classic load balancer, then the network load balancer, and then we have the application load balancer. Let's discuss about the classic load balancer first, which is the previous generation load balancer. Classic load balancer used only with the EC2 classic instances. If you are spinning up the EC2 classic instance, then only you can use the classic load balancer. There is the limitation with the classic load balancer, but that is not the limitation with the EC2 classic. You can use the application and network load balancer as well with the EC2 classic, but classic load balancer can only be used with the EC2, right? So dependency is one way, not both way. Load can be managed on EC2 classic with all kind of load balancer, but for the classic load balancer only, the instance could be the EC2 type only. This is the previous generation load balancer, and also it doesn't allow host based or path based routing. The classic load balancer is the previous generation load balancer, right now. I really doubt that anybody is using the classic load balancer in the AWS, because network load balancer and application load balancer are providing a much better stability and much better application as compared to the classic load balancer. Classic load balancer also doesn't support any host based or the path based routing. We'll discuss about the host based and path based routing shortly. Routing decision can be taken at the transport layer TCP SSL or the application layer HTTP HTTPS. So that is the benefit of the classic load balancer, that the routing decision either can be taken on the fourth layer of the OSI, right, or at the first layer of the OSI, which is HTTP and HTTPS. Fourth layer of the OSI is the TCP. Classic load balancer require a fixed connection between the load balancer port and the container instance port. So that is the another disadvantage with the classic load balancer, that it will require fixed connection between the load balancer port and the container or the application instance port. Then we have the another load balancer, network load balancer. Network load balancer is much better as compared to the classic load balancer, which works at a fourth layer of the OSI, and it use TCP and UDP connections only. So here one thing we can note, network load balancer cannot be used for the HTTP and HTTPS, right? It can only be used for the TCP calls and the UDP connections. Network load balancer can handle million of the requests per second. So if you have a website or if you have an application which is a very volatile in terms of the traffic, right, then network load balancer is a very good option in AWS for you. Network load balancer support the static IP address for the load balancer. You can define the static IP with the load balancer, and all the traffic can be communicate with that particular IP only. Network load balancer supports the routing request to the multiple application on the single EC2 instance. On a single EC2 instance, you can execute multiple applications, and network load balancer, a single load balancer will support all kind of application on the single EC2 instance. The only thing which requires, or the only thing which matters, that all the application must listen on different port, right? You can execute one application on 9090, another one on 8081, another one on 80, another one on 8080. So if we have the multiple application and all the applications are open up for different port on a single EC2 instance, network load balancer can manage that particular thing as well. Here is the simplest example of the network load balancer. Within the VPC, we have the two availability zone A and availability zone B. We have few instances running on AWS availability zone A and few instances on AWS availability zone B. All the incoming traffic will be received by the network load balancer, and then further will send to the across the availability zone, either A or B or on both of the zones. The last load balancer in AWS is the application load balancer, which is a very advanced load balancer. And application load balancer makes routing decision at the application layer. It means HTTP and HTTPS layer of the OSI model, which is the first layer of the OSI model. ALB or application load balancer support path based or the host based routing. What is the path based and what is the host based routing? So whenever you will hit some website, let me show you an example. So we are on the browser. First, see what is the path based routing, right? So let's open some website. Suppose we are going to open the yahoo.com. So here I have opened the yahoo.com, and here you can see inside the URI we are getting in.yahoo.com. We don't have any resource path after this URL. This is the main host. Let's go to some tab. Suppose we are going to the lifestyle. You can see the URL is got changed. URL is now in.style.yahoo.com. If we will go to some another section, if we will go to some another section like astrology, in the lifestyle, the domain is changed, plus also the complete path is also changed. Now we are getting tagged astrology. This is called path based routing. Over here we are specifying a specific path to the specific data. If we will go to some others like celebrity, you can see the path got changed to the celebrity. So application load balancer can also manage these kind of load balancing. You can specify that if we have the multiple set of the EC2 instances, set A, set B and set C, right? On the same domain name, you can specify that if the request is coming to the path slash A, then that will go to the EC2 instances with the set A. If request is coming to the path slash B, then that request will go to the set B EC2 instances, and request is coming to the slash C, then that will go to the set C EC2 instances. In this way, with a single domain name, you can spin up multiple EC2 instances. The typical example can be understood with the help of the e-commerce website. Suppose you have the multiple instances, few instances is running for the cart, few instances are running for the payment gateways, few instances are running for the home page, few instances are running for the sales page. So whenever user is going to a specific URI, whenever user is going to a specific URL, that URL will redirect the user to a specific kind of instances. The instances, if you are going to your on cart, my cart, right, then the instance which are executing for the my cart functionality only, user will redirect to these particular instances. If you are going to some sales page, then the new instance which are running for the current sale, user will redirect to the sales page. If you are going to the if you are going to some specific section like electronics, the instances which are specifically running for the electronic section, the traffic will route to these instances. This is called the path based routing or the host based routing. Host based routing, we have already seen earlier. We was getting the host in .yahoo.com, then the host got changed in.healthcare.yahoo.com. So in that case, if you want, you can redirect user to the some other instances. That is called the path based or the host based routing. And with a single endpoint, we can achieve that particular thing. With a single load balancer, we can achieve that particular thing in the AWS. We can define different EC2 instances, and we can assign these to a specific path so that only these specific path traffic to redirect it to these instances. Cross-zone load balancing is also enabled in the EC2 application load balancer. EC2 application load balancer by default have the cross-zone load balancing enabled, which is disabled in the networking load balancer. Here is the typical example of the ALB. We have a single ALB, and these folders are basically defining different resources or different path or different host. Whenever user is going to hit a specific resource, a specific host, right, that traffic may redirect to the EC2 instances which are running for these hosts only, which are running for these path only, which makes application function more easy. In that case, we have the choice. Suppose for my cart option, I need the low resources machine. I need only 16 core CPU or 8 core CPU machines. So I can spin up the instances of the 16 core, 8 core CPU, and I can configure these instances on a resource path where user have the slash my cart. So all the traffic which is going to your host name slash my cart, only these machine will accept that particular traffic. And suppose there is some kind of sale live on my website, and I need some heavy machine to take care of the traffic. I need 16 core CPU, 32-bit core CPU machine. So I can configure the 64 core or 32 core machine to these resource path only. So this will make the infrastructure management quite easy, and it will also make the system more tolerant as compared to the earlier load balancers. So thank you team. In the coming lecture, we will see how we can spin up the ELB with the help of the Terraform in AWS. Hello team, welcome back. Welcome to Terraform training. And today we will see a lab on AWS ELB. We will see how we can create the elastic load balancer in AWS with auto scaling. So let's go to the code editor and let's create the configuration file for the ELB in AWS. So here we are on the code editor, and inside my section Terraform for AWS Cloud 2, I will create a new folder and I will call it AWS-ELB. What I will do, I will copy few files from the earlier. So I will copy the provider.tf, variable.tf, and paste it here inside the AWS ELB. Right, so we have created the provider.tf and variable.tf. I'm not going to explain the content of these files again and again because we are using these files since starting of this course. What I will do, I will create the new configuration files for the ELB. Now we will create a new file over here and I will call it elb.tf. Inside the elb.tf, we will write down the configuration which will be required to create the ELB in AWS. So over here we have created the ELB resource file, right? We have created the resource AWS underscore ELB, and this is the name of the variable which contains this resource. The name of your ELB will be level up hyphen ELB. If you remember in the earlier lecture, I told you that we need at least two public reason to spin up the ELB, right? So I'm defining one public reason level up hyphen public one, and another one is level up hyphen public two. These are the reasons which I have created inside my VPC. If you go to the earlier lecture, go to the vpc.tf, you can see these are the two public reasons which I have created. I just created my own VPC, so these public reasons are eligible for this particular elb.tf file. Now I am defining the security group, and inside the security group I am defining level up hyphen elb security group. This security group is not defined yet. I will define it so that I can show you the definition of the security group as well. Now we are defining the listeners. The first listener I am defining instance port 80 instance protocol HTTP, load balancer port 80 and load balancer protocol HTTP. It means it will send and receive the traffic on port 80 protocol HTTP. On port 80 protocol HTTP instance will listen the traffic. On port 80 HTTP load balancer will listen the traffic. Then I'm putting the health check. Inside the health check, I'm putting that health check threshold will be 2, unhealthy threshold will be 2, timeout will be 3, target will be HTTP port 80 protocol, interval will be 30 second. What it is mean? It means after each 30 second, this health check will trigger on port 80 by HTTP protocol. The timeout of the health check will be 3 seconds, and it will mark the healthy node after 2 consecutive success, and it will mark the node unhealthy after 2 consecutive failures. Cross zone load balancing true. I told you in ELB cross zone load balancing by default connects true. Connection draining, we are calling connection draining true, and connection draining timeout is 400. Connection draining is another important aspect of the load balancer. If you're not aware with the connection draining, you can Google around it and you can learn about the connection draining. Now, we have defined the resource ELB. What I need to define? I need to define the security group. So I will define the security group for the ELB. So generally team, I'm defining all the resources in a single file. You can see I'm defining the ELB in the same file and security group as well in the same file. But please make sure whenever you are working on the production or in your organization, you keep the things separate. You keep the things in a way like all the security group will be defined in a security group.terraform file. All the ELBs will be mentioned in the ELB.terraform file. All the variables will be present inside the variable.tf file. It will be a good practice to keep the output.tf file for all kind of output which you want from your instances. So you need to learn about the configuration management as well. Over here we are just learning so that we are keeping the things as simple as we can. So team, over here we have created the security group for the ELB, level up hyphen ELB hyphen security group, the same name which I have defined over here, right? The security group I have defined inside the ELB. This is the same name. So this security group is for the ELB. Inside the VPC, I'm taking AWS underscore VPC level up VPC.id. This is the VPC which we have created. The name of your security group will be level up hyphen ELB hyphen SG. Here is the description. Then in the egress, I am taking from port 0 to port 0. It means all the ports. Protocol -1, it means all the protocol and all the IPs. In the ingress, we are only accepting the traffic on port 80 and only sending the traffic to port 80 by TCP protocol on all the IPs. This is the tag, so it doesn't matter. And I'm defining one more security group over here, and this security group is for the instances. So the instances which this particular ELB will manage, this security group will work on these instances. And here you can see the VPC ID is same, which is level of VPC. The name is same as the variable. We have the egress, which is same, port 0, 20, -1, all IPs. We have the ingress, this ingress for the SSH connection on the instance on port 22 from port 22 TCP protocol. But here we have the another ingress, and this ingress for the connection from the ELB. When ELB will try to create connection on the instance, you can see port 80 from port 80 to port 80. Protocol is TCP and security group. Which security group is available? Instead of the CIDR block, I'm taking the security group and taking the security group of the ELB, right? So only the ELB can make the connection on the instance on port 80. None other than ELB can make the connection on the instance on port 80. And same on the ELB, all IPs can make the connection. See, right? In ingress we have the all IPs. So ELB is accessible to the all IPs, but the instance will only accessible on port 80 to ELB. So this is the security we have defined. Now what else we need to define? We need to define the auto scaling, right? So I will create one more file over here and call it auto scaling. If you remember, we have already defined the auto scaling in the earlier lecture, right? So if we will go to the EC2 auto scaling, we have defined a auto scaling.tf over here. Let's do one thing. Let's copy the complete file. We will remove the content which is not required for us. So here we have the AWS launch configuration, level up launch config. It is required, which have the name prefix of the instances, image ID, instance type, and the key name. Then we are defining the key itself. Then we are defining the auto scaling group. Here we need to do some changes. So in the auto scaling.tf, first we have the AWS launch configuration. First change we need in this AWS launch configuration. And what is this change? Name prefix, image ID, instance and key is already available. We need to enter the security group. And what security group will be assigned to the instance? The security group which we have created in the ELB level up hyphen instance. This particular security group will be assigned to the instance because this have the ingress and egress which we required for the ELB. Now what else do we need to define? We need to define some user data as well. Let's execute some script on the instance which is going to be created by this launch configuration, so that with the help of the load balancer we can identify that on which instance the traffic is going to be forwarded. So we will create some user data, and we are creating the user data like this. We are creating a bash script inside the user data bin bash. Then we are updating the package manager. Then we are installing the tool called nettools and nginx. Once the nginx will be installed, what we are doing, we are identifying the IP of the machine with the help of the nettools. And once we will identify the IP, what we are doing, we are writing this particular thing inside the index.html at www http, right? And the message will be, hello team, this is my IP, and you will get the private IP of a machine inside the HTML page. This is defined. Let's do one more thing. I will define a lifecycle as well, and we will choose the lifecycle create before destroy true. So whenever it is going to create an instance, first destroy it if the instance is already exist. So this is the change which we need inside the launch configuration. We don't need any change over here inside the key value pair. Next thing is the auto scaling group. We need some change over here as well. Let's keep the min size 2 because, and max size 2 as well, because if only one instance is running, then how we can identify that the load is basically switching between the instances. And also inside the VPC zone, we need to remove these hard coded zones, and we need to provide the public zone of my custom VPC. So if you remember, we have already provided the public zone of my custom VPC over here. Let's copy these and paste it here inside the auto scaling. Now over here you can see the health check type is EC2. We will change it to the ELB. Now the health check will be done by the ELB, not by the EC2 instances. And after this, we need to assign the load balancer to the AWS auto scaling group as well. So we are defining load balancer AWS underscore ELB, your load balancer variable name dot name. Force delete will be true. Inside the tags, if you want, you can change the value, and we will mention it by load balancer. Now earlier we have defined the alarm and the security policies. We don't need these, right? So I'm going to remove all the policies and alarm, because right now the traffic will be managed by the LB, not by the CloudWatch. Over here, let's do one thing. Let's put the output variables, and inside the output variable we are putting our ELB, right? It will print the endpoint of your ELB. So we have created these number of files, and you can see inside the elb.tf we are using the level up VPC and level up VPC public group. So if you remember, inside the VPC lecture we have created a file vpc.tf. I will copy this file and pasted this file inside the AWS ELB. Now aws.elb have their own vpc.terraform file. Once this will done, you need to commit your code changes. Once the code changes will be done, we will go to the Terraform machine, and over here we will do the git pull. After the git pull, we will go to the directory Terraform for AWS Cloud 2 and go to the AWS ELB. Now we are inside the AWS-ELB. We will put ls, and we have all our files over here: autoscaling.tf, elb.tf, provider.tf, variable.tf, and the vpc.tf. Let's create the SSH key and execute Terraform init. Once Terraform init will done, we will execute the Terraform plan, and you can see Terraform is going to add 18 resources. Let's execute Terraform apply, provide your confirmation, and let's see the resources are basically being created. We have to wait until all of the resources will be created, and you can see all 18 resources are basically created. And inside the output variable ELB, we are getting the ELB endpoint, right? Let's copy this and put a curl and paste it. Hit enter, and it may possible that here we are getting the resource creation, but in between the nginx installation was in progress. So if you will hit the curl and your ELB endpoint after 1 or 2 minutes, you will see you will get the output like this. Hello team, this is my IP. And here I'm getting the IP 10.0.10. It means this machine is created in the US East 2B. If I will hit the curl IP again, here I'm getting the different IP 10.0.1.110. This means it machine created in the US East 2A. Hit it again, getting the IP 210. Hit it again, getting the IP 110. Why I am getting two different IPs again and again? Because in AWS two instances are running, and both of these instances are basically pointed to this ELB. If you want, you can check that. So let's go to the EC2 instances. You can see two instances are running. I will click on the instances. These two instances are running, and the instance name is level up custom EC2 instance by ELB. If you will open any instance, you can see the IP is 10.0.1.10. If you will go with the second one, IP is 10.0.2.10. The same IPs we are getting on our console, 10.0.210, 10.0.1.1110. If you will go to the load balancers, you can see one load balancer level up hyphen ELB is running. If you will go to the instances, then two instances are basically attached to this load balancer. In the description as well, we are getting the DNS name of the load balancer, and this is a type record, right? The same DNS we are hitting over here. If you want, you can copy this and you can directly hit it on the browser as well, because Nginx is a web application, and we are getting the proper message, hello team, this is my IP. If I will refresh my browser, I will get the different IP, refresh it, different IP, refresh it, different IP. So you can see load balancer is basically distributing the load between both of the instances. If you want, you can go to the instance and you can remove any instance from the load balancer. Let's remove the instance from this load balancer, right? Which is in the 2B. I will remove it. You can see now only one instance is present inside the load balancer. What I will do, I will go to browser, paste the ELB endpoint again, and you can see this time I'm getting the IP 10.0.1.110. Refresh it multiple times, you will get the same IP, because we have removed the another node from the load balancer. So this is the way how we can create the EC2 load balancer in AWS, and how we can create the instances and attach these instances to the load balancer. So team, I hope right now it is pretty much clear that how we can create the EC2 load balancer with the help of the Terraform. Let's go to your Terraform and execute Terraform destroy so that it will destroy the resources. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see code modules in Terraform. We will see what is the use of the modules in Terraform and how we can work Terraform with a better way as compared to the last labs. So let's start with and let's discuss about the code modules in Terraform. Till now in this course, we have executed multiple labs. In these labs, what we was doing, we was creating the directory for the Terraform. Then we was creating few files like create instance, variable.tf, provider.tf, and few other lab specific Terraform files. And every time when we was creating the new directory, we was keeping the old files in that directory. We was following a practice to copy the create instance variable.tf and provider.tf from the another directories to the current directory, and we was using them. Till now, if we have created 10 to 12 directories, then in all these 12 directories we was copying the create instance.tf, variable.tf, and provider.tf from the earlier directories. If this way we will work, will that work? Will it make the Terraform most usable software for the deployment automation? Definitely no. A big no. If we can't reuse the code, then definitely there's no point to use the Terraform for the deployment automation, because multiple times we have the requirement, we need to create the multiple instances, or we need to create a single instance in all of the project. Does it mean that we need to copy the all the directories from the previous project to the new project, then some other project, then some other project, and then creating the infrastructure? That is not the ideal way. So what is the ideal way? How we can make the infrastructure code reusable? all the code which is repeatable, how we can make that code reusable, so that we will write down the code at a single place and we will reuse that particular code or the state file at a multiple place whenever we need. Terraform module will solve this problem. Terraform modules will make the Terraform configuration file reusable. So we are already aware with the problem. We have seen these problem in the earlier labs, but let's discuss about a use case with the Terraform configuration file structure. Suppose we have a Terraform file configuration structure like this. We are working on the different environments. We are working on the development environment, we are working on the production environment and staging environment. All these environment have the files like main.tf, main.tf, main.tf. We also have the main.tf at the parent level, which is at the same level of the environment, and we have the provider.tf level. Let's assume we are going to define a new resources in the development environment in main.tf, and that resource will create a new elastic redis instance. So what we will do in the traditional way, we will create the resource definition in the main.tf of the dev, then we will copy the same definition into the production, and then we will copy the same definition into the staging. So that is just about the one resource. Suppose now you are going to create the hundred of resources or the thousand of resources in your infrastructure. So does it really mean that you will copy all these files from dev to production or dev to staging then production? This will create a lot of rework. Plus this will also a error prone solution. There is a lot of chance that you will introduce some error in your production, right? And it may also possible that some configuration you mistakenly forgot to update in the staging or mistakenly forgot to update in the dev. Then your production and the staging environment or production or the dev environment are working on the different configuration, right? So what we need some kind of solution so that we can define the resources at one time, and these resources can be utilized anywhere whenever we need to consume them. And in my case, if we are going to create the Elastic Redis cache in the dev environment, then how we can add a new resource like Elastic cache in that above structure. As a traditional way, we can copy the resource definition in the dev, production, and staging. But what I want, I will create the resource at a one place and I will reuse that resource whenever I required. And the solution of this problem is the Terraform modules. Terraform modules provides a reusable code. We will define the Terraform modules and then we will refer the modules in any Terraform configuration file, and that Terraform module will act like a object. With the Terraform, user can put code inside the Terraform module and reuse that module in the multiple places. We can define the centralized code at a one place and we can refer that centralized code anywhere in the Terraform whenever we required. Modules are the key ingredient to writing the reusable, maintainable, testable Terraform code. Till now, we was working with the very basics. We was not using the reusable code. But going forward, I will show you how we can create the modules and how we can create the reusable code in the Terraform. Terraform's way of creating module is very simple. User need to create a directory that holds the bunch of Terraform files. So whenever we are talking about the Terraform module, we don't need to create any kind of package or any kind of library we do in the Python. We simply create a directory and we will create the Terraform configuration file in that particular directory. That directory will be called as a module in the Terraform, and in all other directories wherever we need that module, we simply refer that module with the help of the source redirective. This is similar to the functions in the programming language. If you ever worked on the programming language, if you have any knowledge of the Java, Python, C Sharp, C, or any programming language, then you must have created the function in the programming language. We create the functions and these function can be called on different set of input variables. So the function is a reusable code in the programming language. Similarly, the module is a reusable code in the Terraform, which can be invoked multiple times in the Terraform with different input sets. Let's see how we can resolve the Elastic Redis cache issue with the Terraform modules. So what we will do, we will create a new directory and we will call it Elastic Cache. And in the Elastic Cache directory, we will create a configuration file main.tf. In this main.tf, which is present inside the Elastic Cache, we will create the resource definition. and then we will refer that main.tf in the other environment main.tf files. So we will create a new directory elastic cache that will be a module for you. In that module we have a one configuration file main.tf, and that main.tf will contain the resource definition. Whenever we need to use the elastic cache as a module, we will use that module inside the dev main.tf or production main.tf or staging main.tf. Using this way, we don't need to create the resource definition in each environment separately, right? We will create the resource definition at a single place, and we just refer that definition in the different environments with the help of the module call. Below is the syntax that can be used to add the elastic cache in the other environment. It means how we can use the elastic cache as a module. So simply need to define module, then the module name, open the curly braces. This is called the body of the module, and here you need to define the source and the relative path of your module. Here you can either define the relative path or the absolute path. There is no limitation, but we need to define the path of the module, that which module I want to include in my Terraform configuration. So suppose we want to include that particular module inside the dev environment. So we will define a module like dev hyphen elastic cache, and source equals to relative path or the complete absolute path of your elastic cache module. And similarly in the production we will define the module production hyphen elastic cache. In the staging we will define module staging hyphen elastic cache. The only thing which you need to remember, that you should change the module name in each of the environment, right? Module name means the name which you are defining for your module inside your configuration file. The source will be similar for all of the environment. Using this way we are defining the elastic cache definition at a one place, and we are using the same definition inside the dev, production and staging without copy anything duplicate. We have seen the one definition of the module, which is reusability. Let's discuss the second definition of the module, which is called configurable module. What is the configurable module? Now the user have the reusable module in place, but here user will hit the another problem. Each environment might have its own requirement from a certain resource. So suppose for elastic cache resource as well, in the dev suppose we want to use the small size, and in the production suppose we want to use the large size, but we have declared the resource definition at a one place. Does it mean that the same resources will be created at all the environment, or we can make the resource size configurable? The answer is we can make the resource size configurable with the help of the variables. So we have discussed the problem scenario, like in dev environment we need just one cache m3 medium machine, and in the production we need cache m3 large machine, right? So how we can do that if the resource definition is declared at a one place? And our issue can be solved by making the module configurable using the input variables. So what we will do, once we will create the resource definition, we will create the resource definition configurable. It means inside the values we kept the variable instead of the actual value, and in the Terraform these variables are configurable, and we can provide different argument to these variable whenever we are calling the module in Terraform. So suppose once we are calling the module in the dev, we will define the value like cache m3 medium or cache m3 small, but same module whenever we are calling for the production, we will define the value like cache m3 large. The definition or the structure of your directory after the configurable module will look like this. In the elastic cache, you have the two configuration file main.tf and variable.tf. Inside the main.tf, the resource value will be called from the variable.tf, and initially variable.tf have the default value, and if we want, we will override the variable.tf values inside the environment dev, production or staging. So as I mentioned, variable.tf file will hold the variable that configure the modules at runtime. Let's discuss the sample variable.tf file in the modules if we are going to take an example of the elastic cache. So we will create a variable file like this: variable environment, which is blank, node count blank, node type blank, and the availability zone, which is a type of list. Now let's take the example of the sample module.tf of the elastic cache module. that will look like this. We will define the resource, then define the resource of the AWS Elastic Cache underscore group. That is the standard name. You can take it from the Terraform registry. Then we are taking the name of the resource. Suppose we are taking it Elastic Cache hyphen cluster. For the availability zone, we are taking the availability zone from the variable. You can see over here we are taking dollar curly braces where dot availability underscore zones, which is defined inside the variable dot tf. Then the replication group ID, we are taking tf hyphen, that is the extension, and then we are taking the environment name from the variable again. Replication group description, we are taking the environment name from the variable. Node type, we are taking the node type from the variable, and number of cache cluster, we are also taking it from the variable. Parameter group name is hard coded over here, port is hard coded over here. So over here inside the module main.tf file, we have all kind of structure. Here we have the static data, which is the parameter group name and the port, and we have the dynamic data, and that dynamic data we are directly reading from the variable file. And variable file have the odd variable defaultly blank. It means once we will use this module in any of the environment, we will dynamically provide the values to these variables, so that each environment will create a specific configuration resource. The definition is same, but the input variable will be different for the each definition. This is a very simple concept, and you can understand it like we are creating the sum function of two numbers, and each time we are calling the function, we are calling the function with two different values, right? So over here we are doing the same thing. We are defining the variable file which is blank by default. We are taking these variables in the resource definition. Whenever I will call this resource definition in any project, I will provide the environment specific variable to the resource, so that that resource will create for that environment specific configuration, not as a hard code configuration which is mentioned inside the Terraform file. Now let's see how we can call these modules. So suppose first we are calling that module in the dev environment. So we will call that module like this. We will define the module, then the name of the module. That could be anything. You can take anything. I'm taking it dev hyphen elastic cache. Then we are defining the source. Inside the source, you need to define the relative or absolute path of your module. For the relative path, you can simply take dot dot slash dot dot slash then the module name. Then we are defining the environment dev, node count 1, node type cache m3 small, and the availability zone. How we are able to take these? So over here you can see all the variables we are defining inside the variable.tf. We are taking the value of these variables when I'm calling the module in the dev environment. So this will create the elastic cache module as per the configuration which I am calling it from the dev environment. For the production, you can call that module like this. The module name will be different. You can take the different name. The source will be same, right? Because we are calling the same module, but the variable will be different. Here the environment is prod, node count as per my production service, node type as per my production service, and availability zone as per my production service. So by this way, you can see the module is a reusable code plus also a reconfigurable code, right? We can call module multiple times with the multiple or different set of values. That is the beauty of the module that make the Terraform code reusable, right? So module is a very important concept of the Terraform. Whenever we are working in the production machine, or we are working on some big project, definitely we need to use the Terraform modules. Without using the Terraform module, you cannot create the stable Terraform infrastructure automation code. Now let's discuss what could be the source of these modules. Source of modules means which could be the source of the modules. Do I really need to create the module every time for my custom configuration? I can use some handy modules available on the internet, and if there's a possibility, then how can I use that? So there could be the three source of the modules. The first is the GitHub. Terraform handy or ready-made modules are present on the GitHub repository. You can directly consume the modules from the GitHub repository. The second source of the module is the registry itself. You remember we was working on the Terraform registry, right? You can use the Terraform registry to get the modules. And the third is the local file path. You can create your own module, and you can define the local file path inside the source, so that you can use your own modules if you don't have any ready-made or the handy module in Terraform, right? So let's go to the browser and let's understand the GitHub or the registry module or local file module source in the Terraform. So we are on the browser. Let's open the registry terraform.io, and here you can see inside the search we are getting the in place text like search providers and modules. So here we can search for the modules as well. Let's search for some modules like EC2 instances, right? And you are getting these search result for the EC2 instance. We are getting few official providers, we are getting some custom providers, we are getting other results as well. Let's go to the see all, and here you can see we are getting few filters and we are getting provider and the modules. Right now it is searching for the module. Here we have the maximum download which is 742K, that is being provided by the AWS. Then we have some custom module from some guy, then we have some custom module from some organization, then we have some custom module from some different organization. Let's go to the provider, and suppose I want to see modules only available from the AWS. So this will provide the modules which is being provided by the AWS. If I will refresh it and we will go to some other, like I want to see the module provided by the Google, there is no module which is being provided by the Google for the EC2 instance. So let's search for the AWS, and here we are getting the Terraform AWS module EC2 instance. And if you want to use that particular module, then here I'm getting the definition. We need to define module, then you can define any name over here, right? There's no mandatory that we need to define EC2 hyphen instance. Here you can see inside the source, this is the way how we can get the registry. If we are using the module from the registry, we can define the module like this: Terraform hyphen AWS module EC2 instances slash AWS. Then it is going to define the version, because this is the version of the Terraform module. The version you are getting over here, so that you can choose your version, right? But the module source will be similar. This is the Terraform AWS module is the parent directory, this is the module name, and this is the provider. If you want, you are working in some organization, you can take your own space on the Terraform registry and you can publish your own module over here. Also we are getting the publish options, right? Provider and the modules. If you can sign in, you can publish your own modules after getting the approval from the Terraform, right? The second way is the GitHub. So over here you can see I'm getting the source code, right? Let's open this source code, and here is the source code, and where that particular source code is present, that present on the github.com. It means we can also consume the Terraform module from the github.com. To consume the Terraform module from the GitHub, you simply need to go to the code, and over here you need to go to the GitHub CLI, and over here you can see you are getting some address: github.com terraform module aws ec2 instance.git. You just need to copy that particular URL inside the source, and that will directly download the module from the GitHub and consume inside your file. So this is the way how we can use the module from the registry or the GitHub. If you want to use the module from the local, then simply in the local file system you can create your own module, and you can refer your module inside your configuration file. There is no challenge to using the local module. So team, we have discussed that how we can make the reusable code and how we can reuse the code in the Terraform. So thank you team. In the next lecture, let's see a lab on the source from GitHub. Hello team, welcome back. Welcome to Terraform training. Today we will see lab on GitHub source. We will see how we can use the module directly download from the GitHub source. So let's open the code editor to create the basic configuration file. So here is my code editor. I will create a new folder inside my Terraform directory, and I will call it Terraform modules. And inside the Terraform module, we will create a Terraform file main.tf. Here we will, in the main.tf, we will mention the code which will be useful to create the EC2 instance with the help of the source code from the GitHub. And inside the main.tf, we will declare a module, define the module name and the module body. Suppose we are defining the module name like EC2 underscore cluster, and inside the module body, first what I need to define, I need to define the source. So I will define the source, and here what source we want to consume. We want to consume the source from the GitHub. So if you remember, in the last lecture we have opened the source code from the GitHub, and here is that particular source code directory, that is terraform hyphen aws modules terraform aws ec2 instance. We will go to the code and we will copy this location, which is https location. Now paste that location over here inside the source, and please make sure we are not using the protocol over here. The source directly start from the github.com, right? After this, what we need to define, definitely if this is the source which is creating the ec2 instance, if you will go to the terraform directory, you can see over here we have the main.tf, output.tf, and the variable.tf. Let's open the main.tf. And main.tf is basically creating the aws instance, and here it is taking the instance count, ami, input types, user data base 64, subnet id, and the other variables as well. This is a very long file, and if you can see that most of the thing it is taking from the variables. If you will open the variables.tf, then here most of the variables are defined, right? Name is defined, instance count was defined, and the type and the default value of the variables is defined. If we are not supplying the variable at runtime, you can see few variable have the type and few variable have the default value as well. Like name don't have the default value, ami don't have the default value, placement group default value is blank, get password default value is false. So the variable which have the default value, we can ignore these variables, but the variable which don't have any default value like name and the ami, we need to provide these variables and the variable value in my terraform configuration file. So what will happen at runtime, once you will consume this module and you will create a configuration file over this module where you are using this module, and you will open and you will execute that configuration file, so that configuration file directly execute this main file from this module, right? And it will create an instance in the terraform. So let's define the undefined values like name, then I think second one was the ami. So we can take the ami from my earlier labs. In the cloud2 variable.tf, you can see this is the ami of the us east 1 and this is the ami of the us east 2. So let's take the ami of the us east 1, and this is the ami. So I will define a variable like ami equals double quotes and provide the ami of the us east 1. Suppose this time I'm going to create the instance in the us east 1. We have defined the ami. Few things like instance type we need to define, so we have defined the instance type as well. We need to define the subnet id as well, so let's define the subnet id. And over here you need to define the subnet of your vpc. If you will go to the browser, open the variable.tf, I think this is the variable.tf, search for the subnet. You can see the default subnet is blank, it means we need to provide some subnet. So we will open the aws console. Once the aws will open, if you remember we have defined the ami of the us east 1, so you need to go to the us east 1, right? We will open the us east 1, we will go to the vpc, then we will go to the subnets of the vpc. Over here we have the default subnets, we will choose any subnet, right? Let's open this subnet, and this is the subnet of the availability zone us east 1b. I will copy this subnet name and provide it here inside my configuration file. Let's define some tags as well. I am defining some tags like terraform true environment dev, and I will save it. So over here you can see I am directly consuming the module from this GitHub repository. I am providing only necessary values like the name of your module, ami of your module, instance type, and the subnet id. Let's do one more thing, create one more file called provider.tf. This is a bug in this module. If you will not provide the if you will not create the provider.tf and you will not provide your provider like aws, then you will not be able to create the ec2 instance, and you will get some error like reason is not defined, right? So we need to make sure that we are defining the provider.tf as well, and we can simply call this provider.tf and paste it here. Instead of the variables, you can do one thing, you can call the direct values. So we are taking us east 1, as a reason, and over here let's keep your access key. So here you need to mention your access key. I'm providing my access key over here, and inside the secret key you can keep it blank, right? We will provide the secret key at runtime. Let's save this and commit this code. The code commit is done. We will go to the Terraform machine. Now we will go to the directory Terraform and we will execute git pull. You can see Terraform modules is basically being created, and main.tf and provider.tf is the part of the Terraform module. We will go to the directory Terraform modules, put ls. We have the Terraform modules over here. Now we need to execute Terraform init. The Terraform initialization is done, and very first line it is saying initializing the modules. And over here you can see it is downloading the module which we have defined inside my source. See, it is downloading the github.com Terraform AWS modules, Terraform AWS EC2 instance.git. First it has downloaded the modules, then it has downloaded the plugins, and it is using the version 3.17.0. Execute Terraform plan, and we are getting the error for the, and we are getting 403. It is authorization error. Let's do one thing. Let's open the Terraform provider.tf, delete the secret key from here, save your file, and now I will export my secret key, AWS secret key, as an environment variable, right? So here I'm exporting my secret key as an environment variable. Why I'm doing it? Because I don't want to upload my secret key on the GitHub, right? This code I have uploaded in my own GitHub repository so that I was able to download the code from my GitHub. See, this is my GitHub repository, Anshul C55 Terraform. So that I'm using the secret key from the environment variables, I have exported the AWS secret key as environment variable. After configure the AWS access key and the secret key in the environment variable, if you want to see, I can show you. Echo $AWS access key. This is my access key, and same echo $AWS secret key, and this is my secret key. Now I will execute the Terraform plan. Terraform plan is successfully executed. We are getting the Terraform plan, and inside the Terraform plan we are getting that AWS instance will be created. Let's execute Terraform apply, provide confirmation, and instance creation is in progress. This will create the instance in your Terraform. So team, you can see I just provided these line of codes. I provided the name, AMI, instance type, subnet ID, and I'm using this particular module which I have downloaded from the GitHub, right? I'm using this module. It will create the AWS instance for me. You can use this module hundred of times or thousand of time in your code, and you can create the AWS instance of your choice. Over here you can see right now I'm executing T2 micro. If I will create one more module over here like EC2 cluster 2, and I will define the instance type T2 small, I will change the subnet, I will change the name, the AMI, this will create another instance. So I don't need to define the complete EC2 instance configuration again and again, again and again. I just need to choose the source from the EC2 instance module from the GitHub and create my own EC2 instance with the configuration variable. These are only necessary and the sample variable. If you want to go through the complete list of the variable which you can provide to your EC2 instance, you can go to the variable.tf file, and over here it has been listed all the variables which you can supply to this particular code. Here is the list of the variables so that you can create a completely customized EC2 instance without doing any configuration of the EC2 instance specific. You just need to provide the variable values, you just need to provide your own configuration, but the Terraform code will be from the GitHub Terraform AWS EC2 instance repository, right? So this is the way how we can use the module from the source GitHub. Simply, if you are using your own, you can define your own module source over here and the variables which is required as per your own implementation. Let's go to the Terraform, and instance is being created. If we will go to the AWS, we will go to the EC2 services. You can see one instance is running. The instance name is my cluster. T2 micro machine and working in US East 1F. Open the instance, and in the details you will find the AMI which you have supplied and the other things like the tags which you have supplied to your machine. See, this is Terraform environment name. These are the tags which I have supplied. So this is the way how we can use the ready-made handy modules with the help of the GitHub source in the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last lecture we have seen how we can use the module from the GitHub source. Today we will generate the module configuration on the local file system and we will use the module from local machine. So let's see how we can generate the module in the local file system and how we can use it. So let's open the code editor. Over here I'm on my code editor Visual Studio, and yesterday we was created this directory terraform underscore modules. Here I have created one more directory called custom VPC. The custom VPC is a directory which I'm going to use as a module in this lecture. So if I will open the custom VPC, you can see custom VPC have the three files provider.tf, variable.tf, vpc.tf, and have the two folders development and development underscore QA. First, let's try to understand the purpose of this custom module. Here we are going to create a custom VPC with the help of the vpc.tf file. Let's open the vpc.tf. You can see I'm defining the AWS VPC as a resource, and over here I'm defining the different parameters which is required for the VPC, like CIDR block range, instance tenancy, enable DNS host name, enable DNS support, classic link DNS support, and assign generate IPv6 CIDR block. Then I'm taking few tags as well, like the name and the environment. But over here you can see I'm not taking the value of any attribute directly. I'm taking all the values from the variables. Here I'm using the variable CIDR, instance tenancy, enable DNS host name, and so on. Inside the tags as well, I'm using the variables. So these variables I have defined inside the variable.tf. Inside the variable.tf, I have defined the access key, I have defined the AWS region, VPC name, CIDR block, instance tenancy, and the other things. Each variable have the description plus the type of the variable and some default value if I'm going to provide. Right, you can see the access key have the default value, AWS region have the default value, US East 2. The default value of the VPC name is blank. The default value of the CIDR block is 0.0.0. With the CIDR block range 0. Instance tenancy default value is already default. Enable DNS hostname default is false. Enable DNS support default is true. Classic link default is null. Classic link DNS support is null. IPv6 default is false, and VPC environment by default it is development. Here the third file which is provider.tf, and inside the provider.tf I'm just taking the provider which is AWS, and reason again I'm reading from the variables. So here are the files, the configuration files, and all these files are basically reading all the values from the variable.tf. Variable.tf have some default value, and as we have already discussed in the theory lecture that we can supply the variable at a runtime. So what I'm going to do, with the help of these three files, I'm going to create two environment, one environment for the development and another environment for the development QA. So let's open the development environment. Over here I'm just defining one file main.tf. Inside the development underscore QA as well, I'm just defining the one file main.tf. Let's open the main.tf of the development environment. You can see here I'm not going to define the resource. Here I'm defining the module, and I'm calling the module name dev-vpc, and I'm taking the source from the local path, right? By this particular way you can define the relative path. This means two directory down. When I'm defining double dot slash, it means one level down. When I'm defining double dot slash, it means two level down. And over here we have the main.tf. If we will go with the one level down, then we will go to the development, but if we will go to the two level down, then we will go to the custom VPC. So over here we are defining the relative path two level down, and what is the module name? Module name is the custom VPC. Then over here I'm defining this development environment specific variable, like the VPC name, which is going to be dev01 VPC, the CIDR block which is 10.0.2.0, CIDR block 24, enable DNS support, enable classic link, enable classic link DNS support, enable IPv6 equals to true, and VPC environment development hyphen engineering. Similarly, in the main.tf file of the development underscore QA, which I'm generating for the QA environment, the module name is different. This is dev hyphen QA hyphen VPC. The source is same, right? Double dot slash double dot custom VPC. Here I'm defining this environment is specific variables. The QA environment is specific variables, like the VPC name will be dev02-QA-VPC. The CIDR block will be 0.10.0.1 instead of the 2. Over here I'm taking IPv6 false. Earlier in the previous main file IPv6 was true. Then I'm taking the environment name like development hyphen QA engineering, and over here I'm taking the AWS region as well, and I'm going to create the development QA VPC in the US East one. You can see inside the main.tf I have not included the AWS region. So how it will take the AWS region, how my development environment VPC will take the AWS region? That will take the AWS region from the default value. And what is the default value of the AWS region? That is US East 2. See, US East 2. So by default, the development VPC will create in the US East 2, but the development QA VPC will be created in the US East 1 as we have defined. So over here you can see I have defined the files at a one place. This is going to be a module, and over here inside my environment, which is a development environment or development QA environment, in both of my environment I'm using the same module as just providing the environment specific values to the VPC. Let's do one thing, let's commit this code. As soon as you will commit the code, let's go to the Terraform machine. So we are on the Terraform machine. We will go to the directory Terraform and get the git pull. You can see the files are being created inside the Terraform module custom VPC. I will clear out the console and go to this Terraform underscore modules custom underscore VPC. Put ls. We have the development directory, we have the development QA directory, and we have the files provider.tf, variable tf, and vpc.tf. Now let's do one thing. Let's go to the development first, right? And over here, what I will do, I will execute the Terraform init. You can see it is initializing the module dev VPC in a custom VPC, right? If you are getting any error over here inside this particular initialization, it means the path you are defining for the source of the module that is not correct. So you need to define the correct relative path of the module. Now I am going to execute the Terraform plan. Team, my access key and secret key is already configured in the environment variable of this machine, so that it is not asking. In your case, your access key and secret key is not configured, then you need to export your access key and the secret key in the environment variables, as we have already discussed in the same course, right? So you can see it is going to add one resource, that is a AWS VPC. Let's execute Terraform apply, and this is the development engineering environment. It is asking for the confirmation. We will provide yes and hit enter button. It is creating the VPC for the development environment. It is done. Now let's go to the another directory, which is development QA, and execute the Terraform init here again. It will create the module, which is custom VPC, download the plugins. Once done, let's execute the Terraform apply directly. Provide your confirmation, hit enter button, and resource is already added. Now both of my, now you can see over here I have defined the VPC definition at a one place, provider at a one place, variable at a one place, but I have used the same definition at a two place with the help of the module. So this is the example how we can reuse the module code, and also with the same definition we have created two modules for two different environment. If we will go to the AWS console, we need to log into our AWS. Now over here we need to check our current region. So right here I'm on US East 2. I will open the VPC, and which VPC network I've created in the US East 2. I think I've created the VPC in the development. You can see I'm getting the two VPC. Let's open the VPC and see I'm getting my custom VPC with the CIDR block range 10.0.2.0 with the 24. Let's go to the definition. You can see this is the default VPC, and IPv6 is enabled associated. This is the IPv6 CIDR block. This is the network layer, and here we are getting the tag dev01 VPC development engineering. In the development engineering VPC, if you will go through development engineering VPC, this is the development engineering VPC. I have not provided the AWS region, so that the default region US East 2 got picked from the variable file. And over here the IPv6 was true, so that I'm getting the same thing in my AWS. IPv6 is true. If I will go to the US East 1, here we have created the VPC for the development QA engineering. Let's go to the VPC and see. The another VPC is also being created over here, but IPv6 range is blank because in the Q environment I have taken the IPv6 false. If you want to see, I will show you in the development QA main.tf. IPv6 was false, right? This was the tag, and this is got created in the US East 1. Why? Because I have defined the US East 1 inside the module definition. This is with the CIDR block 10.0.1. We will go to the tags, development QA engineering dev02 QA VPC. So by this way, we can reuse the module code, and we can reuse the module code, same code with the different environment with the set of the different variables, right? And this is also the way how you can create your own custom module, and how you can use your own custom module in Terraform. If you have any concern, any doubt, you can ask your question in the question and answer forum. Thank you, team. See you in the next lecture. Hello, team. Welcome back. Welcome to Terraform training. And today we will see a lab on AWS VPC module. We will see how we can create the VPC network module, which will have the multiple parts. And later on in next lecture, we will see how we can spin up the instance using that VPC in AWS. So let's go to the code editor and let's see what are the configuration is required for the VPC module in AWS. So earlier we have created this custom VPC module where we just created the VPC but not the attached resources. Today we will create one more directory and we will create a complete network module inside the AWS. So suppose I will create altogether a new directory and I will call it network module. So we have created the directory network module. In this we will create one more directory, and in the network module we will create a directory called module. And inside the module we will create a directory called network. Now in the network we will create the Terraform configuration file and let's call it main.tf, or you can name it anything. I'm going to name the file main.tf. So this file is present inside the network module, then we have the directory module, then the network, and then this file. Over here I will create the VPC resources. Very first we will define the AWS VPC resource, and here we will define the definition of the resource. Here we are defining the definition of the VPC. We are defining the resource AWS VPC. The name of this VPC variable is level up underscore VPC. Then we are defining the CIDR block with the variable CIDR block. Enable DNS supports default true. Enable DNS hostname default true. And we are defining the tags. Inside the tags, we are defining the tag as environment, which will keep the value from the variable environments tag. Next thing, what I'm going to define is about the AWS Internet Gateway. So we have defined the Internet Gateway, AWS Internet Gateway. The name of your gateway will be level up IGT, level up underscore IZW. The VPC ID, here I'm taking the VPC ID of my level up VPC and defining the tag environment variable environment tag. The next thing what I'm going to define is the AWS subnet for this VPC. So we will define the subnet over here. So over here we are defining the AWS subnet. The variable name of the subnet is subnet underscore public. We are defining a VPC ID, AWS level up VPC then ID. Then the CIDR block, we are defining the another variable over here. Earlier we have taken the CIDR block for the CIDR block underscore VPC. Over here for the CIDR block of the subnet, I'm taking the variable CIDR underscore subnet. Map built on IP launch equals to true. Availability zone, I'm taking the availability zone from the variable availability zone. Inside the tags, I'm taking the environment and taking the same variable where underscore environment tag. So we have defined the three resources. Let's define the route table. So I will define AWS route table as well. So over here we are defining the AWS route table. AWS route table. The name of your variable is level up underscore RTB underscore public. Defining the VPC ID, then defining the route. Route will be CIDR block range of the route is 0.0.0.0 with the CIDR block 0. It means all the IPs available on the internet. Then we are going to define the gateway, that which gateway this route will follow. So this route is basically allowing the level up internet gateway. You can see over here I'm taking the AWS internet gateway and the gateway name which we have defined over here. See, we have defined the gateway over here, level up underscore IGW internet gateway, right? So this route we are defining for the public traffic via internet gateway. Then we are defining the environment, and environment is again containing the same variable. After this, once you define the route, you need to define the association as well. So I will define AWS route association. So over here we are defining the route table association, AWS route table association. The name of the route table association will be level up RTA underscore subnet public. Here I'm defining the association with the public subnet which I have created, AWS subnet public. See, here I have created the subnet, and between the route table which we just defined for the internet gateway. So we are opening a connection between the internet gateway and the subnet by this particular association. Rest what I need to define, I need to define the security group. So let's define the security group as well, AWS security group. So over here I'm defining the security group, AWS security group level up SG underscore 22. This is going to be the name of your security group, level up underscore SG22. The VPC ID, I'm taking the VPC ID of the VPC which I've defined in the same resource file. Over here, I'm taking the two rules. The inbound rules is allow traffic from port double two to port double two. This will be a TCP protocol, and the CIDR block what I'm taking is 0.0.0 with the CIDR block 0. It means all the IPs available on the internet. The egress rule is defining from port 0, it means to all port. To port 0, it means allow the traffic to all port. Protocol minus 1, it means all the protocols. And the CIDR block 0.0.0.0 CIDR block 0, it means all the IPs available on the internet. Then I'm going to define the tags, and tag is the same. So this is the file we have defined, and over here in this file we have took a lot of variables. So what I need to do next, so next I need to create a one more file, and I will call it variable.tf. In the variable.tf, I need to take all the variables which we have created or taken over here, like the CIDR VPC, CIDR subnet, CIDR availability zone, environment tag, and all the variables which we have used inside the main.tf. We need to declare these variables over here. So let's declare these variable one by one, or I will declare all the variables in one go, and then we will look into it. Then now we can see here I'm defining few variable like CIDR VPC, and I'm taking the IP range of for the CIDR block 10.1.0 with the CIDR block 16. Then I'm taking the CIDR for the subnet which is 10.1.0.0 with the CIDR block 24. The availability zone I'm taking US East hyphen 2A. The public key path I'm taking level up underscore key dot pub, and the environment tag I'm taking the production. Now let's do one more thing. Let's define one more file and define the output.tf. Over here, suppose we are going to define some output of my VPC. So I will define the output over here. Now inside the output.tf, I am defining few output like the VPC ID. Over here, I'm taking the ID of my VPC. The public subnet ID. Here we are taking the subnet ID of my public subnet and defining the security group ID. Here I am taking the security group ID. So these are the output variable which I have taken. So we have created three files, main.tf which is creating the VPC, internet gateway, route table association, and the security group. Output.tf which will display three output, and the variable.tf which have the variable defined for the main.tf. In the coming lecture, I will show you how we can define the resources outside this module and how we can use this module to create the EC2 instance using this custom VPC. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see the rest of the part of AWS VPC module. We will see how we can create the resource which will use the AWS VPC module to spin up the instance in AWS. So let's go to the code editor and create the configuration file for the instance. So over here we are inside the code editor and we will create a new file inside the network directory. We will call it main.tf. So you can see we have created the main.tf inside the network module. I will close all these files. And in this main.tf, we will define the source code which will help us to spin up the resources which will use the module VPC network. Over here, very first we will define the provider and we will define AWS provider over here, and which will have the one variable reason. So we will get the reason at runtime. Now we will define the next resource, which is a module. Which module I want to use? So I will define module, define my module name. Suppose I'm taking the module name my VPC, then we need to define the source, and inside the source we need to define the module location. So my module location is current directory, then I have the directory module, then I have the directory network. This is the directory, right? This is the source of my module at the current directory where this particular file is present. At the current directory we have the module, and inside the module we have the network. Next thing what we need to define the key pair. So we are defining the key pair like AWS key pair level up underscore key. The key name will be level up underscore key, and the path of the key will be file var dot public key path. This is the variable which we have defined over here inside the variable.tf, public key path, right? Let's close this. Now define the last resource, which is the EC2 instance itself. So over here we have defined the EC2 instance resources, AWS instance. Taking the EC2 instance name level up underscore instance, then the AMI, we will take the AMI from the variable. The instance type, we will take the instance type from the variable again. The subnet ID, over here I'm taking the module, right? Then the network and the public subnet ID. So if you will go to the module and go to the output, over here you can see I'm getting the public subnet ID in output, which will define the subnet ID of your subnet public, right? Of your public subnet. So here I'm taking the subnet ID from the output variable. In the same way, I'm taking the VPC security group ID from the output variable. See, module network SG underscore 22 underscore ID. This is the output variable in your module. Then we are taking the key value pair. The key value pair is AWS key pair, the level up key, which is the name of my key and the key name and the environment. So over here you can see few things we are getting from the variable. It means we also need to define the variable over here. So we will define the file like variable.tf, right? And here we will define the specific variable which is specific to this particular instance. So over here I've defined the variable. The first variable is the reason. I'm taking the reason US East 2. Then we have the public key path. Inside the public key path, I'm taking the level up key dot pub. Then we have the instance AMI. Over here, I'm defining the AMI of the US East 2. In your case, you need to get the latest AMI which you want to use, and you need to define your AMI ID over here. Then we are taking the instance type, which is t2.micro, and then we are taking the environment tag, which is the production. Right? If you want, let's define few variables as well. Let's define output.tf, and here we will get the output of the public IP of my instance. So we are defining the public underscore instance underscore IP, and taking the public IP of AWS instance level up instance under dot public IP. So these are the 6 files which we have defined, 3 files inside the module, and then we are creating the resources and using the module which I created, right? Over here I'm using the network module. Now let's save these files and commit these files. So we have created the custom module network, and we have created few files which will use the custom module, right? In the coming lecture, we will see how we can execute these files in the AWS with the help of the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last 2 lectures, we have seen how we can create the custom network module and the resource which will use this module. Today we will see the execution of that module. So let's go to the Terraform machine, the machine where we are executing the Terraform, and let's try to execute the module which we have created. So we are on the Terraform machine. Let's go to the directory Terraform and execute git pull. You can see all files are being created inside the network module. After the git pull, I will clear out the console and I will go to a path root, then .ssh. Right, put ls over here, and over here I will define the keys. So I will generate a key ssh hyphen keys and then define your key name. Hit enter and generate the key. Why I am defining the key over here? Because in my file, in my variable file, I have taken the key path ssh level up key. It means the root ssh, it means the root dot ssh then level up key. So that I am generating the key over here at this path. Once the key generation will be done, we need to again go to the Terraform. Once the key generation will be done, we will go to the directory Terraform network module and we will execute a command Terraform plan. I can directly execute the Terraform plan without exporting my secret key and access key again and again, because I have defined my secret key and the access key in the environment variable of my machine. So I will execute the Terraform plan and let's see what we will get. And we can see the Terraform plan is successful and it is going to add 8 resources in my AWS. Let's see what are those resources which is going to be created. So the first resource is the AWS instance. The machine is T2 micro. The key is level up key, and then we are getting the AMI ID. The next resource is the AWS key pair. It is reading my AWS key. Internet gateway. Next resource is associate public table. Next resource is route table. Then we have the route table association, security groups. We have the subnet, and we have the VPC. So you can see I have defined the module and now I'm using that module in my code. Let's execute Terraform apply. It will ask for the confirmation, provide yes, hit enter button, and it will create all the resources on your AWS account. Let's wait until all the resources will be created. So you can see most of the resources are basically created. It is creating the instance. So we have to wait until the complete execution will be done. And execution is done. This is the external IP of my AWS instance 18.189.145.145. Let's go to the AWS. Once you go to the AWS, we will go to the specific region. We have created the resource US East 2. We have created the resources in US East 2. So we will go to the US East 2. Here we will go to the VPC and see we are getting multiple VPC over here. Let's go to the VPC. And this is the VPC which is being created, right? Let's open this VPC, go to the tags, and yes, the environment is production. This is the VPC which we have created. You can also identify the VPC with the help of the IPv4 range. Inside the flow logs, we are not getting anything. Inside the CIDR block ranges, we are getting the 10.0.1.1 with the CIDR block 16. If we will go to the subnets, then you can see over here we have the multiple subnet, and this is the subnet which we created, subnet then random ID. Let's open it, and if we will go to the subnet, you can see this is the subnet in US East 2A where we have created with the side range 10.1.0.0 with the 24. If we will go to the tags, we are getting the tags which is production. Go to the route table, we are getting the route table which we have created. Let's open this route table, and this has the route destination 10.0 10.1.0.0 with the setup block 16. This means the VPC internet gateway which we have created. Let's open the internet gateway, and this is the internet gateway which we have created with the help of the network VPC. Now let's go to the EC2 instances. Go to the running instance, and here is the instance which is using, which is T2 micro, and the private IP is 10.1.0. It means it is running in my VPC which I created. Over here you can see the security group is level up underscore SG underscore 22. This is the same security group which we have created inside my network. If you will go to the security group, go to the inbound rules, see SSH connection TCP port 22, source 0.0.0, and if we will go to the outbound, then all traffic, all protocols, all portages, and if we will go tags, tags is the production. So it means all these resources are basically being created with the module which we have used. So team, this is the way how we can use the modules, how we can create the custom module, how we can directly use the module from the GitHub. If you have any doubt, any question, you can ask me. Thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And in this section, we will learn about few advanced thing about the Terraform. We will see how we can put some inbuilt modules, conditional statements, loops inside the Terraform configuration file. So first, today we are starting with the if else. We will see how we can put the if else in Terraform configuration file and what are the benefit of putting the conditional statements in Terraform configuration. So Terraform provide an option to put conditions in HCL, it means HashiCorp configuration language. Till now, we just seen the interpolation in the configuration language, but Terraform provide the conditional support in the configuration language. When we are saying conditional support, it means we can put if else condition in the Terraform configuration language. So booleans can be used in Terraform ternary operation to create the if else statement. So the statement will look like this. We have the condition, then we have the question mark, then we have the true value and the false value. So whenever we are putting the condition, if condition will meet, then true value will be returned. But if condition will not meet, then the false value will be returned. For an example, we can look into this statement. Here, suppose we are getting a resource AWS underscore EIP. The resource variable name is web hyphen EIP. And here we have a property called count. It means we need to count how many AWS EIP we need. We are taking the value from a create EIP variable file, right? And if the value of the create EIP equals to true, then count will be 1. Otherwise, count will be 0. So over here, if the value of this variable create EIP will comes true, it means this statement will justify, then this will return 1, right? Otherwise, if this variable underscore create EIP equals to false, then this will return 0. So this is how the Terraform conditional statement will work. If the value of this create EIP will comes true, then the 1 will be returned. Otherwise, if it comes false, then 0 will be returned, right? Now let's discuss what is the support of the conditional operators. So first is the equality. If we want to check the equality, then to check the equal, we can use the double equals. But if we want to check the not equal, then we need to use the exclamation with the equal. The second is the numeric comparison. We can check with the greater than, less than, greater than equal to, and less than equal to. And then we have the Boolean logic. So the AND condition can be checked with the help of the double ampersand. The OR condition can be checked with the double pipe. And we have the unary condition to check true or false. So this is about the conditional statements in the Terraform configuration file. In the coming lecture, we will see a lab how we can create the number of resources on the base of the development and the production environment. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see a lab on the conditional statement in Terraform. We will see how we can define the conditional statement and we will see how we can manage the resources in AWS with the help of the conditional statement in Terraform. So let's go to the code editor. In my code editor, I will close all the files and I will define a new directory called Terraform Advanced. And in the directory Terraform underscore advanced, we will create a one more directory and we will call it conditional statements. Inside the conditional statement, we will create a file and we will call it create instance.tf. So create instance.tf file is present inside the conditional statement. In this file, what we will do, we will include the module which we have used in earlier lectures on from the source GitHub. So over here inside the Terraform modules, we have created the main.vpc and you can see here we have used the module github.com terraform aws module terraform ec2 instance. I will simply copy this complete file and paste it here. Now I will do the change as per my uses, and over here we will define one more variable and we will call it instance underscore count, and here we will define the instance count on the basis of some condition. So let's define like where dot environment, define question mark, equals. Then inside the environment, let's define production. After the question mark, let's define 2 colon 1. It means if the environment is production, then we need to spin up 2 instances. Otherwise, we need to spin up 1 instance. Here inside the tags as well, let's keep the tag from the variable. We will define one more thing over here, that is the provider. I will define the AWS, and let's provider will accept the reason from the variable AWS underscore reason. So let's create one more file at the same location, and it will called variable.tf. In this file, we will just define two variables. First is the AWS underscore reason, right? And second is the environment. So first we will define the AWS reason, and similarly we will define the another variable called environment. And suppose first I am taking the environment default value as a development. Let's save this and commit this file. As soon as the code commit will done, we will go to the machine where we are executing the Terraform. Once we will go to the machine, we will go to the directory Terraform and we will execute git pull. Git pull is done. You can see Terraform underscore advanced conditional statement create instance is being created. We will go to the Terraform advanced and we will go to the conditional statements. Put ls over here. Both of the files are present. What I need to do first, I need to execute Terraform init, and you can see it is downloading the module from this source which we have defined, and init is done. My AWS access key and secret are already exported in the environment variables. So I will clear out the console and directly execute the Terraform plan. And in the Terraform plan, you can see it is going to add the one resource, right? What is that resource? That resource is the AWS EC2 cluster. Let's execute Terraform apply, provide your confirmation. Now we can see the instance creation is in progress. We have to wait until the instance will be created. Team, please make sure if you are getting any error over here, then in the configuration file we have provided the AMI and the subnet ID. You need to make sure that you are providing the AMI and subnet ID as per the reason which you have defined inside your variable.tf. It means in my case I'm taking it US East 2, so I need to make sure that I will define the subnet ID and the AMI of US East 2. Instance is created. If we will go to the AWS, we will go to the EC2. You can see two instances are running. Over here we can see one instance is running. Let's open this instance, and here is my instance which have the name my cluster. Let's click this instance, and we are getting the tags like development name and Terraform true, right? If we will go to the file, see Terraform true is the tag, environment is the where environment which is the development, and name is my cluster, right? So we are getting all three things. Let's go to the machine again and execute Terraform destroy. Once this will done, we will go to the configuration again and we will put the condition. The condition when we are going to create two instances, when this condition will meet, right? In this case, when I have provided the environment variable development, the condition did not meet and it has executed one instance. Now this time let's define the variable production, right? I will save this, commit this code. Now once you will save the code, let's go to the machine and execute the git pull again, so that we will get the change which we have done. And yes, the change in the variable.tf file. We will execute the Terraform plan again and see. This time we are getting that two resources will be added. Why? Why two resources are going to be added? Because the condition which we have defined for the production is met. Over here we have defined the condition variable environment equals to production. Then we need to spin up the two instances. The instance count could be the true, so that this time when I'm executing this file with the variable production, I'm getting the two resources will be created this time. Let's execute Terraform apply to verify. Once it will ask provide your confirmation, and let's wait until both of the resources will be created. You can see the instance 0 and instance 1. We will go to the AWS and refresh the EC2 dashboard. Go to the instance running state and see two new instance my cluster 1 and my cluster 2 is basically being added in my AWS, right? These are still initializing. It means these are the new instance which we have created. If you will go back to over here, then you can see the two instance are basically created. One have the id f31 and another have the id a2b. If you will go to the AWS, the id is f31 and id is a2b. It means these are the two instances which we just created with the help of the Terraform. Let's click any instance, go to the tags, and this time I'm getting the environment production, so that the two instances will be created. Let's execute Terraform destroy. Once it will ask provide your confirmation. So team, this is the way how we can put the conditions in the Terraform configuration file, and how we can decide on the basis of the variable input that which statement should be executed and which statement should be skipped. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And today we will see built-in functions in Terraform. So we have already discussed about the conditional statements in Terraform. Today we will see what built-in functions are available in the Terraform configuration language, so that we can get the leverage from these functions. So let's start with. In the Terraform configuration language or HCL, user can use the built-in functions because Terraform provides a bunch of built-in functions which are quite helpful in the configuration language. Functions are called with the syntax function name, then you need to define the number of argument which is recommended in the function, right? Some function accept single argument, some function accept multiple argument, some function accept only the string kind of argument, some accept numeric kind of argument, and some accept the list or map kind of argument as well. So we have already seen few functions in our earlier lectures, in our earlier examples or labs. For example, we can understand the file function. If you remember, we are using the file function since long, and we were using the file function to define the public key to the Amazon, right? We also have used the lookup functions in the maps to identify the AMI corresponding to the US East 2, US East 1, US West 2, or US West 1. We will discuss some more functions which are commonly used in the Terraform configuration language, so that whenever you are going to plan or create your configuration file, you can use these functions. The first function I would like to discuss about the base64 encoding. Sometime we need to encrypt the data, we need to encode the string, so we can use the base64 encoding, and we can supply a string to the base64 encode function, so that whatever the string you will supply to this function, this function will return the 64-bit encryption or 64-bit encoding of that particular string. And the similar, to decrypt the string, we have the base64 decode. If you want to decode the base64 encrypted string, then you can use the function base64 decode, and it will return you the actual string after the decryption of the supplied value. The next function we have the chomp. It will accept the string, and it will remove all trailing new lines from the given string. If the string which we are going to supply to this function that have some trailing new lines, then it will remove all the trailing new lines from the given string. Then this is an important function which is called the chunk list. Chunk list will accept the two parameter. First, it will accept the list, and second, it will accept the size. So in the first argument, we can define the list of the values that could be the subnet, that could be the IP range, that could be anything, right? And in the second one, we can supply the size that will return the list items chunked by the size. It means if you are defining a list, right, and you are defining a size 1, then this function will return the number of list, and each list will have the one value. For example, we can understand this in this way. Suppose we have a chunk list AWS subnet, then we are providing some subnet ID, and then we are providing the size is 1. Then the output will be the list, right, and that list will contain a list itself. So over here you can see, if the subnet are 3, then this will return id 1. This is a one list. Id 2, this is the another list, and id 3, this is in the another list. But if we providing like this chunk list variable of the string, and we are defining the size 2, then the output will be chunked, and each inner list will have the two elements, right? So if there are 5 elements, then the first list will have the id1, id2, the second one will have id3 and id4, and the last one will have the id5. So chunk list will chunk the number of list as per the given elements. The next function is the callsec. Callsec will accept the n number of argument and that will return the first non-empty value from the given argument, and at least two argument must be provided. So suppose if we are providing the multiple script and the starting of the argument are basically the null values, then Callsec will find out the first non-empty string and it will return that particular string as a value. Then we have the Callsec list. Callsec list will do the same thing. It will accept the n number of argument and it will return the first non-empty list. If there is empty list in the Callsec list function, then this will return the first non-empty list as a value. The next function which is commonly used is the compact. Compact will supply the list as a argument and it will remove empty string element from the list. So suppose the argument which you are supplying to the compact, that is a list, and if this list have some empty values, then compact function will remove all the empty values from that particular list and return the list which don't have any empty value. So this is a useful function which you will use in your configuration files multiple times whenever you will work on the production systems. To concatenate the number of list, we have the another inbuilt function or built-in function in the Terraform, concat. Concat will accept the n number of list as a argument and it will club or it will combine all the list and it will return a single list which will be the union of all supplied arguments. If you want to identify that a particular list can contain an element, then you can use the contains. You can provide the list and you can provide the element. If that list contain that element, then this function will return true. Otherwise, this function will return false. The next function or inbuilt function is the element that will accept the two argument. First is the list and second is the index. If you want to identify the element present at a particular index, you can use the element function. This function will return the element which is present at a given index. Then we have the file. We have already learned about the file and we are using the file to supply the public key. This will read the content of a file into a string. If you want to identify a length of a list, then you can use the length function in the Terraform. Then we have the next function lookup. This will accept the map value, key value and the default value. We are also using the map in our earlier provider.tf file where we was using the map to identify the AMI corresponding to the. So if you remember, we have created the map. Let me show you an example. If you will open up any old configuration inside the provider, inside the create instance.tf, you can see for the AMI we were using the lookup. The first was the map, variable map, and second was the key. If you will go to the variables.tf, then you can see over here we have the AMI map. The type is map. This is the key and this is the value. This is the key and this is the value. And whenever we will call the lookup, we will call the map and the value. And over here we need to provide the map key. If this key will present in this given map, right, then this will return the value of that particular key. Otherwise, in the lookup you can define the default so that if the key is not present in the map, then the default value will be returned. The next function is the timestamp. Timestamp function will return the UTC timestamp string in RFC 339. Right, that RFC 339 is the timestamp format on which you can Google around it. Timestamp function will return the timestamp. The timestamp function can be helpful in the tags, that can also be helpful in the resource naming convention. Then we have the another function which is also an important function, trim space. It will accept the string as the argument and it will return the copy of the string with trimming all the leading and trailing white space. And the next function is the UUID. UUID will return the random UUID string and this string will change with every invocation of the function. It means each time whenever you will call this function, it will return the unique UUID string. So these are some common and important functions which are present inside the Terraform configuration. Thank you team. See you in the next lecture.